In this video, we'll be looking at chemical bonding. Chemical bonding simply means various attractive forces that join species of atoms, of ions, of molecules together. I take that again. Chemical bonding is simply various attractive forces that joins the species. You can open a bracket now, atoms, ions, and molecules together. That's what we call chemical bonding. Now, when we talk about atoms of elements, all atoms of elements wants to become stable. And for an atom of element to become stable, it must have a duet or a octet configuration. Now, if an atom of element is a duet, it has 2 electrons in the outermost shell. This is known as duet. Now, if it has 8 electrons in the outermost shell, this is known as octet. Now, elements that are duet or octet in their electronic configuration in the outermost shell is stable and unreactive. So, every element wants to become stable in nature. So, this leads to chemical reactions within the atoms of different elements. Now, we have chemical bonding is broadly divided. Chemical bonding is broadly divided into 2. We have 1, we have the intermolecular attraction. We have 2, we have the intramolecular attraction. Or this is called intraatomic forces. Either you call it the intermolecular forces or the intramolecular forces, intramolecular forces or intraatomic forces. Of course, the list under here is 1 ionic force or ionic or electrovalent bonding. Here we also have the pure covalent bonding. Here we also have the dative or the coordinate covalent bonding. Then here we have the metallic bond. Now at the side we have number 1, the weakest force, which is known as Van der Waals force. There are 2 Van der Waals forces which I will list for you. And the first one is the London dispersion force or forces. The next one and the dipole attraction forces or force of attraction. Now, Van der Waals force is considered as the weakest force of attraction, but the particular Van der Waals force that is weaker is the London dispersion forces, although the dipole-dipole force is also weak, but the London dispersion force or force of attraction is weaker than the dipole-dipole force. Then we have the hydrogen bond. All right, now we're going to pick up all these and explain. And the first thing to explain is the ionic bond or the electrovalent bond. Recall, I told you that every element in nature, the one will be stable, the one will be unreactive. Now, the noble gases, because this guy, which is duet and octet, they are known as the noble gases, all right? these noble gases or the group 8 elements are stable and unreactive, okay, ungranted, under extreme conditions like extreme temperature and pressure, they can be forced into reaction. But ordinarily, the noble gases do not react, but ungranted, when they are forced by high temperature and pressure, they can undergo reaction. But normally they don't. All right. So what are we doing in electrovalent or ionic bonding? The force of attraction is between atoms of elements that the electronegativity difference between them is large. The electronegativity difference is about, over here, is about greater than equals to 0.7. The electronegativity difference in atoms of elements which are involved in ionic bonding is about greater than equals to 0.7. That should tell you that the reaction is between pure metals and non-metals. It's purely between metals and non-metals. Now, what is happening here is that atoms of elements with less electronegativity tends to donate or transfer electrons to atoms of elements which have higher electronegativity value. Or you can simply put that it is the transfer of an electron from a metallic atom of element to a non-metal in order to achieve stability or to achieve the position of a noble gas. I take that in another term, but to understand the concept, what is happening here is that electron is transferred from metals to non-metal. Layman language, just ordinarily, electron transfer from metal to non-metal. Or you could say is the transfer of electron from a less electronegative atom of element to a higher electronegative atom of element. But if you don't understand that, take the little one. Electrons are transferred from a metal to a non-metal in order to achieve stability between the atoms of element involved in the reaction. So let's give an example. We have sodium. Sodium has electron configuration 2, 8, 1 because the atomic number for sodium is 11. Let me use a red pen now. So let's say sodium undergoes ionization. The red pen is finishing. Sodium undergoes ionization. And during ionization, is going to lose an electron. You notice that the sodium here becomes 2 and 8. That is, the outermost configuration of sodium at this point is 8, but at this point is 1. Because if you check out the sodium here, we have 1, 2, 3, 4, 5, 6, 7, 8, and then you have 1. So sodium has 1 electron in the outermost shell, but after ionization and it loses an electron, the remaining electron or the remaining outermost shell will have 8 electrons. So we're going to be having over here 1, 2, 3, 4, 5, 6, 7, 8. So you see, when sodium has lost an electron, sodium becomes stable. All right? Because it now has an outermost configuration that is octet, which is the octet that we have here. All right. But another element, we have to receive that electron. And when we receive that electron, it also will now have an octet configuration in its outermost shell. So let's take up chlorine. So let's say chlorine. Chlorine, let's use a red pen now, receive the electron and becomes a negatively charged chlorine. Now what is happening here? Chlorine is 287 at this point before it received the electron. Now 7 plus 1 coming from sodium, it will become 8. So we're going to be having 2, 8, 8. Now because of the space in the board, we're not going to be drawing the structural configuration of chlorine. So just know that as we do this, you can also repeat your diagram here if you want to, and then repeat the 1 for the 8 over there if you want to. Now, what is happening here is that we're not going to be having sodium and then chlorine. Sodium and chlorine. Now, over here, what we'll be having in the outermost share for the 1 of sodium here is 2, 8. Over here is 2, 8, 8. So we're going to have a net positive charge, a net negative charge. So this will form the sodium chloride, all right? Because electron is transferred from sodium, and the electron that is transferred is received by the chlorine and to form a stable sodium chloride. So it just makes sense to you. Let me find something to make more illustration for you. This is what is happening. So I have sodium. We say sodium has the outermost shell of sodium is just 1. So it has just